Okay, so I am Danish bin Muhammad Rafid and I'll be presenting the introduction to this presentation. We did a shoe store database. So in this presentation, we will cover the introduction, the ERD, the queries, the drawbacks and future improvements, and the conclusion. This is our team, SHREETHAR, Danish, me, VISHAL, DINESH, and FAUZY. So for this database project, we have decided to build a database for shoe stores that sell various types of shoes, from hiking shoes, high heels, sport shoes. This database was made through Oracle Apex and applies multiple topics that we have learned through the semester. Some of the topics include entity relationship diagram using Draw.io and the creation of tables using Oracle Apex with SQL. So the problems that this database will state or fix is an inability to easily compile data and extrapolate for sale improvement, the difficulty to view and manage data, and consequently, this will cause a lot of extra labor just to view sale data. The objective is to simplify and compact the time taken for sale improvement analyzation, to structure data and attributes to eliminate redundancies, and to cut down on extra labor costs. So this will help sale management teams, accountants, and chief financial officers of companies. So we will move on to the ERD.
So here we got uh, so now I will explain the things that we got in the EOD. So here we have two bridge entity, which is the employee the commission entity and the order list entity. Bridge entity is the one that have the strong relationship. And so most of the relation is okay. So the customer and the order, we got the one and only one to zero and many, because customer can make zero or more than one order, but each of the order is made by only one customer. Here, the payment and delivery method is one and only one, both side with the order. Employee also have the same relation with the customer and order, which is one and only one and zero to many. Commission and order also get one and only one relation. Order and order list, or here, each of the order must have at least one or many order lists, because customer might purchase more than one type of shoes, and each of the order list must be only under one order. Then we got the shoes. Yes. Here the shoes is one or many, because the quantity of the shoes. Oh, I said just now we got more than one shoes. If the customer can buy more than one shoes, not only one type of shoes. That's why we use one or many. And the supplier, we are one to many. One or many. So the highest okay. From here you can see the highest degree table is order, which it have at least 5 degree. Yes. And yes, I think that's all from me. Thank you very much.
Hello, I am Vishal and I will be presenting the shoe store database queries. So firstly, we have the query to find the total sales amount by each employee. We have the query to find intersected values of columns from two tables. We have the query to list information from two tables based on what is available on both tables. The query to find the average order value per customer. The query to list all orders and include delivery information based on the table on the left. Query to find the most popular shoe brand by sales volume. So I will also be presenting this SQL code on Oracle Apex and displaying the tables together. Alright. Firstly, we have the query to find the total sales amount by each employee. So here's the code. So the code functions this way. We will select the columns from employee ID and employee name from the table employee. We will sum up the total price column from the table order list using the sum function, and we will display it as total sales amount. We will join together the commission table, the order table, and the order list together with the employee table, and we will group it by the employee name and the employee ID columns, and we will order it by the total sales amount in descending order. So here are the tables, and the total sales amount is arranged in descending order, right? Now for the second code, I will demonstrate the query to find intersected values of two tables. So we will select the column order ID from table order list and will intersect it with the column order ID from the table commission. We will run this. So these are the IDs available from both tables that contain these IDs. Therefore, if there is one ID on one table but there isn't on the other, it will not be displayed here, only if it is available in both tables. Okay. For the third query, I will be presenting the query to list information from two tables based on what is available on both tables. So we will select the columns order ID, customer ID, customer name, customer contact number, customer address, and total price from the tables order list, customer. So we will take the table from order list and we will inner join it with the customer table on the customer ID column on both tables. So this will display whatever customer ID or whatever information that is available on both tables only. If there is information that is available on, for example, the order list table but is not available on the customer table, it will not be displayed in this table. Now for the fourth query, it is a query to find the average order value per customer. So we will select the columns customer ID and customer name from the table customer, and we will average it through the total price column from the order list table using the average function, and we will display it as average order value. So we will join the tables order list with the customer table on the column order ID, customer ID, and we will group it by the customer ID and the customer name columns, and then we will order it by the average order value in descending order. As displayed here, it is in descending order. Okay, the fifth query is the query to list all orders and include delivery information based on the table on the left. So this, we select the columns order ID, customer ID, total price, courier name, and delivery method from the tables order list and delivery. So from the table order list, we left outer join it with the table delivery on the column order ID and deliver ID. So what this will do is, this will display the information that is available primarily on the left table, which is the order list table. So if the value in delivery ID does not exist, it will show a null value. For the sixth query, I will be presenting the query to find the most popular shoe brand by sales volume. So this code, we select the brand name column and we sum up the total price column from the table order list, and we display it as a total sales volume. So from the table shoe, and we join it with the table order list on the column shoe ID on each tables, and we group it by the brand name and then we order it by the sum of the total price column in descending order as displayed here. So thank you from me. That is all the queries that we have prepared.
First, let's discuss some of the drawbacks we identified. One major issue is redundant data storage. In our order list table, we store customer ID, which is unnecessary because it can be derived from order table using order ID. This redundancy can lead to data inconsistency. Next, we found inconsistency in data types. For example, the contact number field has different length in different table, which is VAR chart 255 in customer, VAR chart 20 in employee, supplier, and delivery. This inconsistency can lead to data truncation or unnecessary storage usage. The next is lack of not null constraints. It's important columns like customer name, employee name, payment method, and shoe ID lack not null constraints. Without these constraints, our data integrity is at risk, and as essential field might be left empty. Now let's look at our future improvement for our plan. First, we will ensure consistency in data types and lengths across all tables. Specifically, contact number should have a consistent length and type in customer, employee, delivery, and supplier tables. We will also address normalization and redundancy by removing the customer ID from the order list table. We eliminate unnecessary duplication since it can be referenced through order ID. Next, we will adopt consistent column naming convention. For example, contact number should have the same length and type across all tables, promoting uniformly. Finally, we will add not null constraints where appropriate to ensure data integrity. Fields like customer name, employee name, and email address should always have values to maintain the accuracy of our data.
Hi, I'm SHREETHAR and I would like to talk about the conclusion for our database project. The database system designed by the given data declaration language statements represents a comprehensive structure for managing a shoe store's operation, including customers, employees, orders, payment, deliveries, suppliers, and commission. While the design captures essential relationships and data points, several areas for improvement can enhance its efficiency, data integrity, and consistency, since a well-designed database schema is crucial for the efficient operation of any business application. While the initial design provides a solid foundation, continuous evaluation and optimization are necessary to ensure the system remains robust, efficient, and scalable. By addressing the identified drawbacks and implementing the suggested improvements, the database system can better support the shoe store's operation, providing reliable and actionable insight for decision making. That's all from me. Thank you.